Okay, so far I have been talking about uh, this gentleman, Alexander Hamilton, who had a great idea. Okay, well, there was there were a few people who actually did not like Hamilton. Okay, and in fact, if you have seen the musical Alexander Hamilton, you know who they are, and in particular, you know who that one person is. Here he is, Thomas Jefferson. Okay, he became the first secretary of what? Um, Hamilton was the secretary of the Treasury, and Jefferson was not the president back then, but he had a strong friend in a man named George Washington. So let's see what happened to this apportionment problem when Jefferson, the arch rival of Hamilton, opposed Hamilton's method. We will go back to the notes. All right, so Hamilton had a politically powerful enemy. His name was Thomas Jefferson. Okay, a Virginian, born in the United States in the state of Virginia, and he later became the president. At this point, he was not. He was a refined, distinguished person who had served as the ambassador of the United States to France. He was very educated, and in fact, he was a geometer and an architecture. In fact, he eventually built the original buildings of the University of Virginia in Charlottesville. Okay, so what happened, right? So this is what happened. I'm going to write this because sentence is probably the best way to represent this. Jefferson did not like Hamilton, nor did he like his method. Basically, I think he opposed Hamilton's method personally because he didn't like Hamilton, but there's another reason for it. We'll talk about why else Jefferson opposed Hamilton's method. But anyway, he didn't like that Hamilton's method, not because of the Alabama paradox, because neither of these men knew that Alabama paradox could happen. But Jefferson did not like Hamilton's method. So he came up with his own method. Remember, he was a mathematician. He was a very educated mathematician, geometer, and lots of other things, astronomer, architect, and so on. So he came up with his own method, which is the next thing we are going to study, Jefferson's method, right? And not surprisingly, his method favored larger states like Virginia. You see how much of a politician he was? Okay, yeah, so, and bigger states, all right? So he came up with a method which will give the advantage to his own state, the home state of Virginia. Okay, and so let's study this method now. All right, in Jefferson's method, what we do is this. Okay, now again, you have to remember these two methods. And by the way, there are like 3 or 4 other methods described in the book in this section. But because of our time constraints, we are only going to focus on Hamilton's method and Jefferson's method. Okay, so just focus on these two methods. Under Jefferson's method, we actually round down each quota. Okay, we're not going to even consider the remainders, right? So we do not use the remainders, the portions after the decimal point. Okay, if more seats are available, which we usually do see, we reduce that standard divisors, the standard divisor called D, and we are going to modify it. And so the new number, the new divisor is called a modified divisor. And we keep lowering that number until the total number is obtained. Okay, so let's apply Jefferson's method to the same 4-state country consisting of states A, B, C, and D with a total population of 5,830 as we did before. Okay, so the quota, all right, so let's see, we are going to go back to assume that we have 28 seats. Okay, so this is the initial problem we had before adding that extra seats. All right, so because we have 28 seats, all right, so the original divisor, remember we did this calculation before, 5,830 divided by 28, and we had our first standard divisor, which was 208.2143. Okay, so the quota is the population divided by 208.2143, right? And so if you do that, well, we had these numbers before, 1.891, 9.298, and 4.034, 13.179. And if you're wondering, if you have seen these numbers, yes, we did. That's exactly the same numbers that we saw up here on page 1, right? And that's because we are using the same formulas here. Okay. Now remember the minimum quotas. The minimum quotas are 19413. They did not add up to 28. They add up to 27. So we needed one more. And at that point, okay, at this point, under Hamilton's method, we looked at the remainders. This time we are not going to look at the remainders. Jefferson decided to change this quota, to mess with this quota. 208 is obviously too big, because that's how we got 27 only. All right. So let's start to reduce it, to lower it, to decrease this number to, let's say, 200. And then do the same. Well, it didn't work. Okay. How about 199? It didn't work. How about 197? It didn't work. Okay. And so you have to actually, do a bunch of trial and error to see which one actually works. Okay. Unless you use a different algorithm, which there is one. But anyway, so in this particular situation, it turns out that the modified divisor of 195 would work. Okay, now how do you know this number works? Well, you have to try some numbers. Okay, Excel spreadsheet will be very helpful to find this number if you have to do this over and over again, because none of these numbers, even though they are all smaller than 208, would not work. Okay, but once you get to 195, it turns out this works. Okay, so let's go ahead and do this. 310 divided by 195, that would be 1.590. Okay, this number divided by 195 is 9.928. This number divided by 198 is 4.308. This divided by 195 is 14.072. Okay, now remember, we are not going to pay attention to the remainders, so don't even worry about the remainders. All we are looking at is that integer part, the part that comes before the decimal point. Remember, that's how we find our minimum quota. We always round down. So we're going to round down these numbers, 1, 9, 4. And look at this. What used to be 13.179 is now 14 point something, okay? Because we modified the divisor, okay, significantly enough that this number became 13 point something to 14 point something. So we lower or round down each quota to the largest integer, which does not exceed these numbers. So that's 1, 9, 4, and 14. This, of course, because this number went up by 1, we add up these numbers and you get 28. And that is the method by Jefferson. All right, now the thing is, in the previous, so compared to our first table, which is at the bottom of page 1, this is the change of -1. So compared to Hamilton's method, state A gets 1 fewer representatives. This is the same, and this is the same, and D, which happens to be the largest state, gets 1 extra, right? And this is the key. All right, this is why Jefferson liked it, because back then, his home state, the state of Virginia, now the Commonwealth of Virginia, but the state of Virginia was a very large state. And Jefferson's method, mathematically speaking, is going to favor larger states. You see how 13 became 14 very quickly when you start changing numbers here. Look at these numbers. 1.489 didn't change much to, it's only to 1.590. Larger numbers are influenced or affected much more by change in the divisor. Jefferson, as an expert in mathematics as well as politics, knew exactly what would happen with this kind of method. So he proposed this method, which today is known as Jefferson's method. Okay, again, just reviewing this, we always round down, but instead of looking at the remainders, we start changing the divisor, keep lowering and lowering until such a number, this one here, until such a value that would cause the minimum quotas to add up to 28. Okay, and when I say minimum quotas, all I'm telling you to do is to look at these numbers before the decimal point. Okay, we always round down, which means we always just truncate, these parts. Okay, and once you can do this and the seeds add up to the number that you desire, then you are done. Hopefully this makes sense. Okay, so please let me add little explanations to summarize what we're talking about. Okay, Jefferson's method does not consider remainders. Okay, get that? A new divisor smaller than the standard divisor is used. We always round down, i.e. truncate the quotas in Jefferson's method. Okay, but because the standard divisor is now modified to be the modified divisor, we continue to modify it until the quotas, the minimum quotas, the truncated minimum quotas add up to the number of the total number of seats for the representatives. Okay, so that is called Jefferson's method. Now, the book also goes on to talk about Webster's method. And then there are a few other methods described in the exercises at the end of the section. We are not going to worry about this, all right? So in your homework, if you start looking at your homework problems, and if it has any reference to Webster's method, that part can be skipped. Make sure you just do only the Hamilton's method and Jefferson's method problems, okay? In Webster's method, we actually round up or down using the standard usual rounding method, 4 and less goes down, 5 and more goes up, and so on. And so it is more of a sort of a standard rounding method that is used in Webster's method. If more seats are available, use Jefferson's method. If the total number of seats exceeds the seats, then you increase the standard divisor. So Webster's method is very much like Jefferson's method, except it allows for rounding up or down in each step. Several other methods are mentioned in this book, section 8.1, but we do not worry about that. Okay, now there is a page 3 to this notes. This is the first time you saw a third page on your notes, right? But that's because I want you to know what really happened in the history of apportionment. And by the way, the apportionment became a huge topic recently after the 2020 census. If you remember, places like New York and California lost a seat because the population went down. Some states also added the seats, and then they became a huge controversy because the state of New York ended up losing a seat only by like 89 people who did not get counted. And who knows what's going to happen. All right, you can read more about this recent topic in the news at the end of the chapter. If you go to the end of chapter 8, you see for further explanations or for further explorations, that section discusses what happens in the 2020 census and the new apportionment, which, by the way, does not use Hamilton's method or Jefferson's method anymore. Okay, so here's what happened in the history of this country. All right, so remember in 1791, this is when the Congress decided, hey, Hamilton's method is great, so let's use Hamilton's method. Okay, so the Congress passed the law that says we shall use Hamilton's method in apportioning our the House of Representative members. Well, so if the Congress, the both chambers of the Congress approved something, then that almost becomes a law, right? Well, there's one more step that is required for a bill to become a law, and that is the signature of the president, the United States president. So the president back then was, of course, a man by the name of George Washington, who is also from the state of Virginia, a friend, a very good friend of Thomas Jefferson. And because Jefferson did not like Hamilton nor his method, Jefferson came up with his own idea. Well, the Congress, in contrast, actually passed Hamilton's method, right? Because they liked Hamilton's method. Well, the president actually has a power to say, no, I don't want to make this into a law. What is that procedure called? Veto, all right? So Washington actually vetoed Hamilton's method to be used to apportion the newly established House of Representatives. Okay, so my version of the story or the narrative goes like this: Jefferson goes to his good buddy George Washington, probably sipping on his favorite French wine or something. Say, George, here's my my favorite French wine. I think you would like this. And they're talking, and they say, look, Hamilton's method was passed by the Congress, but you and I wouldn't like this because this does not favor our great state of Virginia. So let's make Virginia great again. And so Washington says, oh, that's a great idea. So they decided that Washington should veto this Hamilton's method. And by the way, this is the very first veto exercised by the US president. Okay, and this happened with Hamilton's method. So the very first veto by a US president in the history of this country was to veto Hamilton's method. Okay, a little trivia that you may want to remember. All right, so what did they use? Okay, well, they actually used, of course, Jefferson's method for the first half a century or so, right? And the House, of course, back then had a very few representatives, 105 representatives. Today, we have over 400 members in the House of Representatives. Okay, now for just a brief moment, in fact, once, because there was the 1840 census, and following that, they decided to use what? Webster's method. Okay, and that was used once because Webster thought this was a great idea, and the Congress agreed. So they and remember, these are very similar methods. So instead of Jefferson's method, which people realized would almost always favor larger states, they saw the trick of Jefferson by that time, and they say, you know what? Let's just not do that. Let's use a fairer method, and that's Webster's method. Okay, but soon after that, they realized, you know what? Hamilton actually had a good idea. He had passed away by this time. He was killed in a duel, as many of you know, by a guy named Aaron Burr. So he was long gone by that time. But he was exonerated many years after his death because at that point, following the 1850 census, the country decided to adopt Hamilton's method. Okay, so Hamilton's method is used for like 50 years until, through the Civil War, until in 1880, Alabama became upset because Hamilton's method created that Alabama paradox. So this was decided that it's decided that this was not a fair method. All right, so what did the country do after that? Well, they went back to the only other known method which was considered fair, which was Webster's, right? So for about 40 years or so, following the discovery of the Alabama paradox, they went back to Webster's method was used again, right? Well into the 20th century. And in fact, there was 1 year where they did not agree, right? So the methods of apportionment was so controversial. Did you know that they used to have these arguments and debates and ugly fights between politicians? Yeah, this goes way back. You would think that we would get better as time goes by, but it didn't get better. It just got worse. Okay, and of course that's not a surprise because today we see political fights as well, right? Anyway, so the politicians couldn't agree, and after the 1920 census, they actually didn't do apportionment like the Constitution says we have to. So the methods of apportionment was so controversial that no reapportionment was actually done following the 1920 census, right? So because this was such a controversial matter, the US government invited two mathematicians to do what? Okay, let me go ahead and write this. Two mathematicians, and these are like the economics and mathematicians. So the economists / mathematicians, two mathematicians for better apportionment methods. Okay, they wanted to have a good apportionment method that is perfect, that is fair. And in 1941, a new method called, surprisingly, named after these two mathematicians, Huntington-Hill method. Right? These two mathematicians were Huntington and Hill. And so they, and many, I mean, both of these men were very knowledgeable both in mathematics and statistics. And so they proposed a method. And in 1941, which is following the 1940 census, right in the middle of World War II, the country adopted the Huntington-Hill method, sometimes called the Hill-Huntington method. And this is the method still used today, okay? So we today use Huntington-Hill, the Huntington-Hill method. This is almost identical to Webster's method, by the way. The only difference is, and the major difference is, in this method, we use what is called the geometric ratios or geometric means for rounding. You know how the usual rounding is, right? The usual rounding is used for Webster's method. So you look at the number after where you want to round up or down. And if that number following is 4 or less, we round down. If it's 5 or more, you round up. That's the usual rounding. But instead of that usual rounding, the method by Huntington and Hill uses what is known as the geometric methods. I'm not going to get into it, geometric means, by the way. I'm not going to get into it, but you should read more about this topic if you're interested. At the end of this chapter, chapter 8, in the section called For Further Explanations or For Further Explorations, to see what happened after the 2020 census. Okay. So now let me try to conclude by giving you just a few remarks at the end. Basically, I'll tell you what happened, and you can read more about this in the book. After the 2020 census, New York lost a seat. Okay, the last seat. So they had extra seats to give away, just like in Hamilton's method. The last seat went to Minnesota, okay? And New York was next. They would have been the next, but New York lost by 89 people. Okay, so if the census result had 89 more people living in New York, then the state of New York would have not lost a seat, and the Minnesota would not have gained that seat. So this is actually a pretty controversial situation. We will see what happens. Okay. Now, the Alabama paradox was not considered desirable, and so it actually violated what is known as one of the fairness criteria. Okay, so what the economists and experts in political scientists did is to list what should be considered a fair method. What is fair in apportionment? Okay, so they listed several things called fairness criteria. The Alabama paradox, remember what that was? A state losing a seat because the total size of the Congress got bigger. So that should never happen. So they say, well, that violates a fairness criterion. We don't think it should happen. So experts have identified a few other criteria like this. okay, along with the other paradoxes. And you can read more about this in section 1.8 of the 8.1 of the book. So then the natural question is Huntington-Hill method fair? Does it always satisfy all the fairness criteria that they came up with? The answer is no, okay? And in fact, here's the sort of the bad conclusion of the story. The answer is no, nobody has ever come up with a method that is always going to satisfy all of the fairness criteria. In fact, every method has flaws. Okay, so we are still waiting for, are we still waiting for a perfect method of apportionment? And the answer is no. Why not? Okay, because in 1983, Belinsky and Young, two economists, proved mathematically there is no apportionment method that satisfies all fairness criteria all the time. Okay, so in other words, life is not fair. Not only did they prove that the methods that we have mentioned do not satisfy the fairness criteria, what they proved is that regardless of what method anybody can come up with now or in the future, okay, there can be no method that would be guaranteed to satisfy all fairness criteria. In other words, they proved that such a perfect method cannot exist and does not exist, and they proved it mathematically. Now, to prove something doesn't exist is actually much harder than you may think, because what you have to show is that no matter how smart it is and no matter how many years people try, no one can come up with one, because logically there cannot be any fair apportionment methods. Okay, but that's what they proved in 1983. Basically, they proved that apportionment is never fair, or not always fair, or there's no fair apportionment method. Okay, so with that sort of a sad, depressing note, I will end section 8.1. But your opportunity here is to do what we did with Hamilton's method here and Jefferson's method. Go ahead, and I'm giving you specifically the modified divisor to be used for Jefferson's method. But here is your chance to work on both Hamilton's method and Jefferson's method to be applied to a high school district to apportion the 40 counselors available. All right, that is your whole quiz for this section. And of course, once you get these numbers, you should go and do this online so that you can get credit for your online quiz for section 8.1. All right, in the next section, we'll talk about gerrymandering, another big topic in politics. All right, so until then, I hope you have a great day and take care.